Hello, welcome to another episode of Short and Sweet. Hopefully, this will be that for a quick toolkit on vectors and trigonometry. Now, a vector is something that has a magnitude and a direction. In this case, this would be our magnitude, and this would be our direction, an angle that we call theta. So we can draw a little arrow at it, and we can tell you this is a Greek letter called theta, and we write that because we're just too lazy to write the angle under discussion. Now, in the physics classroom, we use trigonometry, but sometimes we use it a little bit differently. Instead of calling it adjacent and opposite and hypotenuse, we cheat and do some other things. This side here, left, right, this is the x direction, right? So it turns out that the x is equal to the resulting vector times the cosine of theta. Now you go, that's great, but what's the resultant vector? This is the resultant vector. Because it's going to be the results of what happens with the x. Now, it's not that simple. Of course, naturally we have y, which is equal to r sine theta. In fact, I probably should make this, to make it color coding, is keep you straight here and just simply say the r is the black and the sine theta. Now, you may or may not remember from some other things on trigonometry, but we also end up with, let's see, our friend here, theta is equal to the arctangent of y over the value of x. And some of you eyes are probably rolling at this point in time. Let's go through this a little bit more. This is your left-right part, so how far you go there would be this value times the cosine of the angle. Now, angles have a cosine angle number that's between 0 and 1. It's a decimal. And it's actually the fraction there. So like sine, let's see if we can pick a nice color for that. The sine of the angle is equal to the values of the opposite side opposite, and that's what this is called. And this is the side adjacent to this angle called theta. And this is known as the hypotenuse. Or if you like, c squared BA. So the sine is opposite divided by the value of the hypotenuse. And in standard trigonometric tables, we make h equal to 1 and do that. The Greeks worked this out years ago. Cosine is equal to adjacent over hypotenuse as a fraction, which is a decimal number. The tangent, as I put in before, is equal to opposite over adjacent, or if you like, sine theta over cosine theta. And you might remember Pythagorean's theorem, c squared equals a squared plus b squared. This all gets back to that. Now let's see what we can do about turning this into something that you can use in class without having to do a whole trigonometry table. Let's first replace out our things. I think I have another one of these. There we go. You probably remember that horrible triangle that's called 3, 4, 5. So if I make this side equal to 3, and I make this side equal to 4, everybody probably has already gone, yeah, and this side's equal to 5. But can I verify this? Well, we already determined that tangent, or stated that the arctangent is equal to the values of y over x, which is equal to 4 over 3. So if you look on a table where you have made the hypotenuse equal to 1, you will come out with what angle goes with 1.333. And if you hit those values, you'll find out that tangent is equal to 53.13 degrees for this theta on a 3, 4, 5 triangle. Well, let's test this out. I said earlier that x, how much my component in the left-right direction, is equal to r times the cosine of theta. Well, my r, we set it to be 1, so 1 times the cosine of 5315, 15313, right? So if I go cosine 53.13, I get the number 0.6000. But this is equal, x is basically equal to 0.6 of the units. Now I can do the same thing for my friend y here and say y is equal to 1 times the sine of 5313. So when I say sine 53.13, I get the number, basically y equals 1 times 0.8, or y equals 0.8. Well, remember we said r squared equals x squared plus y squared. Of course, we said a squared plus b squared equals c squared, or in this case, r equals the square root of x squared plus y squared. So if we go back here, we can add that in there, x squared plus y squared. Let's try our luck. 0.6 squared is 0.36 plus 0.8 squared, some of you already probably done in your head and said 0.64, equals r squared. So r squared equals 1 squared, square root of that, r equals 1, which is right back where we're starting from. So this very short proof works. Now I'm sure you probably tired of that triangle, so let's try another one. Some that you may not have seen as much. A different